Good day, students. This is Ma'am Bea, your science teacher, and today we are going to talk about earthquakes and faults. The following are the learning competencies that are expected for you to achieve in this lesson. First, you are to explain how movement along faults generate earthquakes. And then second, you are to differentiate the epicenter by its focus, the intensity of an earthquake from its magnitude, and also you are going to differentiate active and inactive faults. Before we proceed to the lesson proper, let us first have a quick guessing game for everyone to check if you have learned something prior to the discussion of our topic. We have here a game called Guess the GIF. So I am going to show you some clips and then you are going to describe what is happening in the picture and you will answer by guessing what is it. Are you ready? Let's start. Okay, this is the first one. Try to observe what is happening in the screen or in the clip shown in the screen. The objects are moving, right? And then take a look at the text below saying gasps. So definitely the cartoon character gasps. Now, based on that observation, what do you think is happening in the picture? There is definitely an earthquake. So as you can see, the objects around him are moving. How about this one? What can you say about the waves shown in the screen? There are big waves, right? Or shall we say huge waves to be exact. Now, what comes into your mind when in the ocean or sea there is a huge wave that comes towards the coastline or the seashore? What do you call that phenomenon? There is definitely a tsunami. What about this? I believe you can picture that out as two pieces of land grinding with each other. What are your other observations? Well, these two land portions might have broke apart from each other, right? What do you call this event where the ground is grinding or shaking against each other? And then, what do you call to that break in between the ground during an earthquake? That is definitely a fault, and that is what we're going to talk about in our lesson. What is a fault? A fault is a break in the Earth's crust, and along the break, significant movement has taken place. In the last figure that is shown in the screen a while ago, there are two portions of land that is definitely broken and grinding with each other. That break that is grinding is what we call as faults. The word break refers to a crack in the ground, while crust refers to the outmost layer of the earth. And we are living on the surface of the crust, not inside or outside the earth, but in the surface. So there is a movement that happened in the earth's crust that resulted to the breaking of the soil. Significantly, movement means that the rocks have been displaced or shifted considerably. When the movement happened, the rocks and the other components of the crust, such as soil, have been displaced from one place to the other. The picture below is an example of an image of the San Andreas Fault in California. It is the biggest fault recorded so far, which is famous because data reports said that when this fault line moves, there will be a huge disaster that will destroy a large part of the land. What are the different types of faults? In this lesson, we are going to discuss 3 types of faults. Is the normal fault. This refers to the movement of the crust where the block above the inclined fault moves down relative to the block below the fault, which is caused by extensional forces and results in extension, like to what is shown in the illustration below. The inclined fault moves down the surface, and the resulting fault due to the movement is called normal fault. Next, we have the reverse fault. This refers to the movement of the Earth's crust where the block above the inclined fault moves up relative to the block below the fault. So this fault motion is caused by compressional forces and results in shortening. So a reverse fault is called a thrust fault if the dip of the fault plane is small. So this is the opposite of the normal fault, as you can see in the illustration below. In reverse fault, the movement is upward, while the inclined fault in the normal type of fault moves downward. The last type of fault that we are going to talk about is what we call strike-slip fault. So in strike-slip fault, the crust moves horizontal and the fault plane is nearly vertical. If the block on the far side of the fault moves to the left, as what is shown in this animation below, the fault is called left lateral. However, if the block moves to the right, the fault is called right lateral. The fault motion of a strike-slip fault is caused by shearing forces. This is what I mean when I said that the crust is grinding with each other. Next, we are going to talk about how do faults generate earthquakes. So take note that when there is a fault, earthquake can possibly occur. Just like when the fault moves, definitely earthquake happens. Earthquakes occur on faults. It occurs when rock shifts or slips along fault lines. Earthquakes generate waves that travel through the Earth's surface. These waves are what is felt and cause damage around the epicenter of the earthquake. When faults move, earthquakes occur, and then these earthquakes generates waves that travels in the earth. These waves are responsible for the shaking and grinding in the Earth's surface that cause damage on the buildings, houses, and other infrastructures, and even damages in nature itself. Let us now define what is an earthquake. Earthquakes are vibrations or tremors produced within the Earth's outer layer, which is the crust. An earthquake is tectonic. It occurs when parts of the Earth's crust break, and also the rocks together with a fault slide near each other or far away from each other. This is often called faulting. So earthquakes are the movement in the tectonic plates of the crust, which is the outermost layer of the earth. These are vibrations that is produced due to the grinding and shaking of the fault lines found in the earth's crust. The whole earth is composed of tectonic plates that move, so earthquake happens from time to time. In the previous slide, we talked about earthquake as a tectonic movement. Well, an earthquake can also be volcanic. Tremors are often produced to signal an upcoming discharge at a vicinity or a region where a volcano is located. The produced earthquakes are due to the movement of the magma inside the magma chamber of a volcano. Thus, it sends waves or vibrations in which we will be able to feel when a volcano is about to erupt. And Did you know that Philippines have 21 active volcanoes? So, meaning they will erupt in time, thus we feel earthquakes from time to time. Now, let us compare an earthquake's focus and epicenter. As we all know, the pressure in the Earth's crust is responsible for the movement of the rocks. The place where the earthquake originates is called focus. The Earth's surface directly above the focus is where you can find the epicenter. Take a look at the picture below. As you can see, you have there the fault, the diagonal line across, which is also called the inclined fault. And then, where the shaking or the grinding happens is the hypocenter or the focus. So this is where the earthquake originates. And then, just right above it is the epicenter. So the epicenter is where the waves that the earthquakes produced is being felt and causes damage. Okay. There are two major scales which earthquakes are measured. We have magnitude and then intensity. Magnitude is the entire energy released by an earthquake at its focus, while intensity gives us an idea of how strong or weak the shaking is. So, the magnitude refers to the energy released at its focus, and the intensity refers to the force, either how strong or weak the earthquake is. Again, intensity refers to how strong or weak the earthquake is. And this chart is an example of the earthquake intensity scale that PHIVOLCS used to identify the intensity of an earthquake in the Philippines. By the way, PHIVOLCS is an abbreviation for Philippine Institute of Volcanology and Seismology. So, for example, when an earthquake is scarcely perceptible, it falls on intensity 1, while if the earthquake is completely devastating, it falls on intensity 10. So there are descriptions here at the right portion of the scale, and then the intensity is at the left portion. Earthquakes occurrences can also be measured through the former oscillations and today's oscillations that come from faults. Oscillations refers to the movement of faults from one place to the other. Nevertheless, different method is by inspecting the surroundings. This is the map of the Philippines showing the distribution of the faults and trenches in the country. As you can see, there are red and purple symbols and lines there in the map, and this marks the faults, trenches, and collision zones in the Philippines. It is really important for us to be knowledgeable enough about earthquakes and faults for us to identify if a specific place is safe when we build something like a house, for example, because there are consequences accompanying any faults. For example, a residence was constructed on a portion of the land where there is a fault down below. So as the spot displaces slowly, portions of the residence will be steered, and then the ground will fracture, and these openings will no longer shut, and then the roof may begin to drip. So it is really important for us to know about earthquakes and faults so that we may know where to build a house or something. There are also what we call active and inactive faults. An active fault is the one that has moved in the past and is suspected to move again. The place where these faults are located are those earthquake-prone areas because of its ability to move again. Inactive faults, on the other hand, are structures that we can identify but which do not have earthquakes. These faults are just cracks and will not move. Experts adopt various techniques to uncover out if a fault is active. One is by reviewing the country's past recordings. Archaeologists periodically record about disruptive incidents such as earthquakes. So earthquakes are destructive and can extremely be devastating. It could steal lives and it can destroy an entire city or even an island. Let us now talk about two types of earthquake waves. P waves. P waves are compressional waves. As what you can see, the waves are inward and outward and is traveling in the direction of propagation. P waves travel fastest and are the first to arrive from the earthquake. Next, we have S waves or shear waves. These waves travels perpendicular to the direction of wave propagation, thus cannot easily arrive from the earthquake because it is not directly going towards the direction of propagation. This is the instrument that is used to record the motion of the ground during an earthquake, and it is called a seismograph. The picture below shows an example of this instrument. Trivia time! Did you know that earthquakes are responsible for the production of tsunamis? These are the giant waves that speeds along as fast as jet planes produce because of a movement of a fault in an ocean floor or volcanic eruptions under the sea. These waves travels from its point of origin towards the seashore, devouring everything where these pass through. It could be houses, buildings, trees, and other things near the shore, and even living things. And that is all for today. Thank you for listening. I hope you have learned something new. By the way, this is Ma'am Bea, your science teacher. Until next time!